are sufficient to cover a fundamentals of a course. We are not getting into the mathematical part of this course, right? We have not exposing the different algorithms, different expressions, any fundamental equations. We have not discussed that part, right? Because most of the students are having this perception that information retrieval requires a lot of mathematical part. Yes, it is true, but we have not discussed it because it depends on your application area, right? Naturally, in the course of information retrieval, information search, or web search, you need to implement a few equations, which we say mathematical models, in this retrieval model, which we are trying to now start or now to open it, right? In the last class, we have discussed a concept called relevance estimation. There also you can have some mathematical approach to capture, to model it, right? So that is one part. Second part is this matching part, which we are going to discuss today. So if you combine both this matching and ranking, so for both part, you need to have some formula, you need to have some model. Like in the case of optimization, whenever you are writing an optimization algorithm, so I hope you are reading it in the soft computing course. So whenever you we want to design a optimization algorithm to find out the optimal solution, you need to write a fitness function, right? Naturally, along with the fitness function, you should be having some approach to, like in the case of genetic algorithm, if you want to design a solution for genetic algorithm based solution, you need to write an approach to generate the crossover, to perform the crossover with crossover probability. You need to perform mutation with mutation probability. So for a GA based solution, you need to write some strategy to generate the crossover, perform mutation, and to perform the this selection part also. Along with these 2-3 steps, you need to write a fitness function, right? So that is up to you. So basically, in the most of the GA-based solutions, people are not working in these first 3-4 steps. They are simply adapting the fundamental way of performing crossover, fundamental way of mutation, fundamental of selection. But when it comes to fitness function, so most of the solutions are basically having a change or novelty into the fitness function part only, right? So similarly, if you're designing, trying to design an information retrieval system, you can adopt all these pre-steps. So any other steps except retrieval model part, you can adapt any conventional or traditional approach, right? And when it comes to the retrieval model part, which is the core of any retrieval system, you can have new formula, you can have new model, you can have a new measure matrix to perform or to estimate the relevance, to estimate the ranking, right? And most of the systems are you can say are unique only in this part, right? So if you compare this Flipkart or maybe Amazon or any services, if you closely monitor them, you will find that they are having this uniqueness onto this part only: relevance estimation and ranking generation. That's it. So naturally, for that, they are having their own way of utilizing the data, because to perform estimation of both relevance and ranking, relevance and similarity, you need to utilize some features, some information, some data, right? So by using these two, you can arrange them in a formula, in an equation, and generate some equation, some numeric value, right? So that is the only difference, and that's why we are not getting into it. Naturally, in the upcoming lecture, last 9 lectures, we will be discussing 3-4 use cases. There we will be opening about how basically retrieval model works in the case of question answer based system, how it works in the recommender system, how it works in the different domains, right? So let's see. So if you have anything to raise or discuss related to mid-semester 2, if you have any objections, if you have any concerns, you can share maybe after this lecture. And now we will be strictly monitoring your attendance, because we are now heading towards the semester end. So your class performance is naturally coming from this quizzes which we have, but attendance is important. We will not having all the students in one range, right? So it is very important to be on the class lecture. During the lecture, you should be present, and attendance is being recorded. If anyone is not into the class, it should be recorded also, right? So last 10 or 9 lectures are important. They are important in all aspects actually. So let me see. Let me share the notes. Yes. Right. So well in the place. So we have discussed or started discussing this component called matching and ranking. And in this we have partially discussed the ranking part, right? And we have said that to perform a ranking or to rank the retrieve results, you need to use the relevance estimation, the relevance value, relevance, we can see relevance score, you can say broadly, right? And naturally, to perform ranking or to rank the data, you need to have a set of retrieved to set of matched results, right? So that's where the second part comes, which is called matching. And we have said to perform matching in any kind of system, you need to perform matching, and naturally matching will be performed by having some set of similarity measures, right? So similarity measures are the first thing which has been designed or proposed by the first generation of data scientists or information scientists to get an idea that this is how we can derive the matching. And it is a very limited area of research. Very few people has designed or proposed the similarity measures, right? And that's why it is said that okay, most of the information systems, most of the modern information systems are not having any experiment at this layer, at the similarity layer, at the matching process layer. They are having this privilege to be have new measures, to be have new idea at the ranking part. There we can have new relevance approaches, new relevance measures. So most of the changes, most of the novelties are being done in the second layer, which is ranking, not in the matching layer. So by this, you can have this clarity that in an information retrieval system, it is not necessary always to have the ranking model. You can have a retrieval system without having the ranking approach, without having relevance measures, by simply having a matching algorithm to match, measures to match, measures to similarity estimation. You can always successfully run a retrieval system, right? So in the modern information systems, naturally this retrieval model. So I'm saying retrieval model, not retrieval process or retrieval system, right? So it is entirely different to retrieval process or retrieval system, right? So I'm saying it is model because we can have always. So whenever we say model, it means it is a representation or it is an implementation of idea or maybe a particular conceptualization. So when I say retrieval model, it means it will have some mathematical form, mathematical equation, mathematical expression, which expresses, which models a conceptual understanding, right? So when we see retrieval model, it will always have these two subsystems, right, based on the requirements. Like I have said, for any retrieval process, for any retrieval system, you should always has a matching process. So matching process is something which is basically you can say is a mandatory part, you can say, right? So it is mandatory. But ranking is always optional because sometimes system does not require any kind of ranking because it fetches only few limited set of results. Right now, after getting these two components into the retrieval model, naturally, because matching is essential, you should have always some set of ideas, some set of matrices. So to perform these two, we have to perform relevance estimation and similarity measures. That is equivalent. That is well discussed in the previous lectures also. So by the definition, if you take basically retrieval model is basically having three broad components, three main components, and most of the you can see the modern information retrieval systems are having some set of changes, some set of evolutions in one of these three parts, right? So naturally, one part is this retrieval. Within the retrieval model, you can see that's match and rank. These are the two sub processes defined, and along with these two, we have this query model and the data representation model. So whenever a question is raised to you, what are the components of a retrieval model, you should always have this idea that it will have three parts. First part is document representation, second part is query representation, and third part is the matching function. Matching function, or maybe you can say matching and ranking function, right? So retrieval model does not have only this ranking or matching process or matching or ranking algorithm. It will always has this query and data representation inside the definition, right? The reason is that whenever you want to perform an algorithm, you should have the compatible, or you can say the similar type of inputs, right? So that's why for retrieval model, this this small q is the input, and small d is the input, right? So that's why it is important to have a similar model, similar representation, right? So that then only you can perform some set of match and rank. So that's why it is very important to have a specific type of representation, specific type of to denote the data, to denote the query, right? Like if you are trying to develop a retrieval system or search system on the social media platform, or maybe Facebook or maybe Twitter, you need to represent the data into the maybe the graph form, graph way, right? So because graph is something which captures each and every semantics of the social media data. So once you capture the social media data and represents into the graphical representation, you need to map the user's query into the graph also. So there you can have graph-based query representation, something like that. And to perform a retrieval process, perform the matching and ranking, you need to have this compatibility. You need to have this formula which simply matches the node or maybe the edge value, something like that, right? So you need to have this understanding that whenever we are designing a query information system or maybe query retrieval system, you should always align to a specific query and data representation model which is compatible to the retrieval models and its algorithm for matching and ranking. So these two are the very important basically points are there, right? So whenever we are adapting or designing an information retrieval system, you should be always having this inclination. Beyond these two aspects, like the models for query and data and retrieval model, other aspects are nothing to do with the internal structure of these two. So like you can have always a new approach to capture the information needs. You can always have a new approach to capture the document data, database on index database. You can always have a new components or new system arrangements within the evaluation systems. So you can capture anything, you can have these things into any shape in these components. But if you want to design this retrieval model, you should always take care about the representation of query and data, and then matching and its compatibility with matching and ranking algorithm, right? That's the bottom line. Now, if you further understand that what is the purpose of retrieval model. So retrieval model simply implements the relevance, overall relevance level. You can say the degree, right? It is to implement the degree, and it is to implement the scale or scope, which is basically between the user query and the document, which is basically required to be achieved or required to be implemented, right? So you can see typically we have taken this concept called relevance during the previous lecture with respect to that, with respect to the scale, that how it is basically implemented between the query and its respect with data document set, right? Now further, because in the matching process also, during the matching process also, we are trying to achieve some sort of relevance, right? So if you combine both ranking and matching processes, both are trying to basically implement or achieve some sort of relevance, have some sort of similarity on between the user query and document set, right? So in the case of matching also, we are achieving or we are implementing some sort of degree of relevance. So if you take this concept called what could be the possible, the basic or the first way of performing the match. So if you have given a set of documents and there is a user query, so between these two, what is the basic or what is the first version of matching? So it could be simply says, or it could be simply have a mechanism which simply says the results could be a relevant or it could be a non-relevant. So it's basically this, by this you can say it could be in the form of 0 or ones, right? So you can have this decision that this is matching, means it is 1, it is matching. So for given query, these set of documents are having their presence, they are matching with them. So you can assign 1, 1, 1, go to them. And for remaining, which are not having any matching or any similarity, you can have, or you can assign simply 0. So the basic or the layman way or the classical approach of deriving the matching between the set of documents and between a given user query, it could be the binary way, it could be the Boolean way, right? So that's why we are saying the Boolean retrieval model is one of the classical approach. I'm not saying traditional, it is a classical, right? So classical means it is the first way of achieving it. It is the first way of implementation. So to perform matching between user query and document, this could be the first, this could be the best way we can have. Though it is having some limitation. Limitation is like it is okay, it is perfectly compatible, or it is perfectly fine for the cases where we are trying to get the exact match-based results, right? So it again requires the best or rectified or verified query, because when we type a keyword with incorrect means, it will not fetch any result to you, right? So it again has some limitation because it requires a lot of skills to the user. He has to always type a correct or exact query, then only the results will be fetched, right? So it is again having a lot of limitations. It is having a lot of restrictions, at least for the user concern, not for the system concern, because system, once you type the query in correct queries type, you will get always a lot of matching results. So its limitation lies in the user side, because for the query correction, you need a lot of algorithm. You need to have a lot of arrangements, right? And naturally, whenever there is this match between user query and data, you need to have some operators, and those operators are called comparison operators, right? So we will be discussing upon this part. So as far as design concerned, so whenever we are implementing a classical approach like binary matching or Boolean based retrieval model for matching, two things are very important: that how you have been represented the user query, and how documents have been represented, and how these matchings between query and documents has been achieved. What are the different operators you have been using, right? So if you have one single term in a query, you can simply perform match, right? And suppose user query is having more than one keyword, how these two keywords in the user query are mapped or matched on the query representation. What is the arrangement of comparison operators, right? So these are the specific area of concern which are actually right now they are well addressed. We are not having any limitation on the available binary or Boolean based retrieval models. Yes, they are not old models. This Boolean retrieval model are widely used by the different retrieval systems. The challenge only lies where basically how you are using the operators, how you are arranging the operators to perform the match between query and documents. For this particular part, there are various advancements has been proposed. So you must have heard about the advanced Boolean operators, advanced Boolean retrieval models. So the change happens only in this part, that how they have basically achieved the modified operators. So you can always propose a new operator to perform this Boolean matching, right? So this operator aspect is one of the aspects where most of the people are working. So you can always propose new operator to perform the matching, right? So the basic Boolean model can be adapted, and new operator can be proposed to perform the Boolean retrieval model retrieval based. something like that, right? So this is one of the classical model. Naturally, if you are experimenting with the operators, comparison operators, you can always have a new Boolean based operator, or you can have always new retrieval model, because you have proposed the new comparison operator. As far as query and document representation concerned, Boolean or maybe binary classical approach based matching is always preferring or always prefers the text-based, simple text-based representation. It says, okay, you can have the set of documents, and you can always derive or surrogate data in the terms of text. Simple text processing can serve this purpose. Right now, going to the next step, because in the binary representation or binary retrieval model is having only two level of relevance, a two level of matching, relevant and non-relevant, which is the most obvious, most abstract way. Now, it has been observed that, okay, it is not always the case that user is having this accuracy, this certainty of his matching, or of the matching on the data for his query. So it says, or theoretically you can say, now the matching has been defined into the three levels. Now for some data sets it is okay, it is matching. For some it is not matching. But for some data set or for some data documents objects, user is not sure whether they are matching or not. So the advanced or the second generation of retrieval model captures this third possible aspect of matching, or third aspect of relevance, as an unsure, uncertainty, right, unaware, something like that. So this third aspect of third degree of matching is being captured into the most of the modern retrieval models, right? And it says we are going to capture all the possible exact matchings, partial matching on the documents between user query and document set. So you must have heard about the different data or different retrieval models, like vector space, language based, knowledge based, semantic based, all those things. So all these remaining set of types of retrieval models are based on this philosophy, that they are capturing this third dimension, which is said as a unsure, uncertain part of it. So for relevant part, whichever documents are relevant, it means it will be having the exact match. And for those which are not matching at all, they are going to this block which is called non-relevant. But there are a third block which is occurring in most of the system. Most of the models are capturing it. It is said as unsure, but it is the difficult part which is implemented, which is designed in the most of the modern retrieval systems, right? Now, beyond this, naturally, to capture this unsure or uncertain part into the retrieval process, they have adapted, or they have employed some statistical estimates, right? So that is some measure, that is some one of the critical part of matching process, and that is the complex part also, you can say, because capturing the uncertainty is again one of the complex tasks of computer science. It is one of the complex tasks of computing, right? So for that, you can always have your statistical estimation based on some data, based on some observation, right? And then you can have the list of documents. So on the top, or maybe on the top 10 pages, or maybe top on the first page, you can have always the relevant documents, and on the second page onwards, you can have the partially matched results, right? So that is how each and every information system is doing. They are displaying the matching results, relevant or exact matching results in the first top pages, and remaining will be pushed on the later pages, something like that. But you should have some estimate to identify that this result is matching, maybe with the lesser score of match, right? So for that, because if it is showing some interest, some matches, maybe 0.001, but it is not a non-relevant result. It is having some matching. It is having some similarity. So for that, you need to adapt a particular estimate, a particular similarity measure. right? To perform to identify the relevant match, you may need or maybe different similarity measure. To perform the estimation for unsure set of results, you need to have different or maybe additional similarity matrix. That's what is the theories, right? So most of the systems which are having this modern approach for retrieval process are having two similarity matrices. One is to perform the relevance, second is to perform the unsure part of data, unsure set of results, right? Naturally, it is having a lot of design issues because you're having two similarity metrics, two similarity measures. Then to make them compatible, you need to have a very specific, very refined way of query and data representation. So in both sides, you are having little concern, but with the presence of vector representation, with the presence of word-to-vec representation, so most of the modern information retrieval are having unique way of representation. This traditional way of data representation will not work. You should have a different or unique way of data representation for query and document both, right? So these are the basic information about the two broad categories or the two broad classes of retrieval models. And if you take any number of any retrieval model available into the internet or maybe in the literature, if you go through it and in its semantics, you will easily identify that it is falling into the classical or the modern, right? So one of the classical classification available in the internet is like this. So most of the traditional is written here. So in the both, we have not written as classical or modern into the graph. So in the image, you can see it is said as a traditional information retrieval model. So tradition means it is still being used by the different systems or different individuals, right? So in this, you can see the classification is defined onto the different characteristics. So first type of it is said as a set theoretic. Second one is says it is algebraic, and third one is called probabilistic, right? So this algebraic and probabilistics are falling into the modern type of retrieval models, algebraic and probabilistic. But set theoretic retrieval models are purely the classical retrieval models. So you can see here, this Boolean based is placed. Then we can say extended Boolean is placed. In some cases, fuzzy set is also considered as a classical. For some, it is case-based reasoning also, right? And a set theoretic is it referred because it is purely having this classification approach that okay, the matchings of the documents will be performed into these two sets, relevant and non-relevant, right? Yes, within the relevant, you can have further splits, the labels of it. That's what it is done in the fuzzy set also. But in case of algebraic and probabilistic, in case of both, the main thrust, the main difference is in the on the part and the approach where they are adapting for the unsure set of results. That is how they are deriving. So in the both case, algebraic and probabilistic, they are having two different similarity matrices, similarity measures to identify the unsure set of results and the relevant set of results, right? So naturally, out of these given set of retrieval models, we will be discussing about at least four. So like Boolean, we will be discussing Boolean, then extended Boolean, then we'll take a vectors based, then we will take neural network based, and then we'll take probabilistic based, right? So maybe probabilistic or maybe inference network based. And if you explore into the literature, you will find that there are various extensions of probabilistics are available. There are various extension of inference networks are available. So most of the recent works are just the extension of these established retrieval models, right? So in the next lecture, we will be opening about these different types of retrieval by a specific example to understand that is how it is working upon, right? So going to next, let's see how different researchers has interpreted the retrieval model, right? So I'm having four interpretations of the retrieval model, or rather you can say it is a retrieval process. So in the very first diagram, you can see here, In this part, one of the researchers has interpreted the whole retrieval process, right? You can see. So in here, this text collection is set as a document database. Then they have adapted a representation and organization. Then they have derived the text surrogates, right? So this is something we are referring as a surrogate data. And this surrogate data will be utilized for comparison, you can see. And from the back end, or from the as a feedback or a feed, you can say relevance feedback, actually it is getting something from the back end, from the evaluation component, or maybe directly from the relevance. So that is there, and it will be coming to the text surrogate part only. And this is what one of the researchers has interpreted. So after getting the text surrogate, it is sent to the comparison of our interaction. In the parallel side, you can see the information needs are, or maybe understanding is pushed or maybe represented in the form of some GUI or form of some arrangement, and it is in the form of query, and it is sent to the comparison. So this is how one of the presentation, one of the understanding can be drawn. So that's what I am saying from the very first lecture, that for the same system, for the same process, you can have any ways of representation. And this is the representation for the retrieval process, entire retrieval process, right? Now, if you go to the next representation, which is widely available by some of the researchers or in some of the books, actually. So you can see here, the top, you can see the document collection, then it is sent or transformed into the conceptual analysis, and then they have transformation. And this transformation is kept. So transformation is basically derived in the form of document surrogates. Now, this document surrogate information is sent to the matching process. So the process which we are discussing from the last two lectures, at least, ranking and matching, both. Now, to perform this matching, naturally, you need query. So now query is coming from the bottom. So here the information needs at the bottom, you can see information needs at the problem, then it's conceptual analysis, then it's conceptual query, then it's directly transformation is shown. So this transformation is basically in the form of query surrogate, and this is again sent to the matching process. Naturally, at the implementation level, you will have different components. Like here, the index vocabulary has been shared because it is being utilized to perform some sort of transformation, right? So you can see, so this index vocab has been used to perform the transformation of data, as well as transformation of a query, right? So this is one of the other alternate representation of the same retrieval model or same retrieval query. Now, there is third option available. So here it is the most brief, actually. It is not capturing the internal steps for it. So here you can skip this feedback part. Now, user is placed, user is sending his requirement or required information in the form of query. Query is sent to IR system, right? Parallel to it, there is a document set. Document is sent to, or maybe derived index are sent to indexing process. Then indexing terms have shared some indexes, and these indexes are being shared to the IR system, and IR system performs matching, right? Now going to the last part, last presentation. This is, I think, is the most detailed way. Now you can see here, naturally we have search intent. The search intent is transformed into the form of query. Here also you can ignore the feedback part. So, so query is basically sent to a block called compare query X with the document. That's one track. Parallel to this, in the internal part of the system, documents are now extracted, and one sort of representation is shared where D1 is represented as 11011. So this is sort of vector representation, or maybe you can say a sort of index representation. If you invert them into the form of words, so it is called inverted index. So that is again a representation. So sometimes inverted index are referred as a surrogate data also. So that depends upon the representation which you are adapting for your system. So this index, inverted index, is basically sent to the comparison process, because in the inverted index the words are available, W1, W2, W6. But in the case of index representation, we have kept documents, and within the documents which word is available, right? So if you use index data to perform comparison, it will not serve the purpose because it is not having the compatible representation, right? Because in query you will have W's, but in the document data you are having documents, not words. So that's why we need to convert sometimes index data into the form of inverted index, right? Now, based on this inverted index, you can easily perform the comparison, and this result will be directly sent to the user. And based on some feedback, you can always improve your system. This particular last fourth figure is taken from one of the book which is widely used by the students to read to understand this such process. Now, again, let's take one of the typical use case of IR process. So, can you tell me what kind of what is the application area which whose IR process explained? So you can see a GUI for query setup, GUI for the display, and then this user query is posted in the form of acoustic query. This query is sent for audio representation. Then naturally, because your query is an audio query, so you need to represent it, you need to transform it, and after transformation you need to send to the matching process. Parallel to it, you can see acoustic music database on the bottom. So there also they are having audio representation. This audio representation is sent to the metadatabase, and this metadatabase is being utilized to perform the matching process, and all the matching process matching results will be displayed into the GUI, right? Naturally, there are some matrices being captured whenever a matching is performed, right? So this is typical, the layout or typical conceptual view of a retrieval model you can have. This is how each and every interpretation of a retrieval model, retrieval process, and its position of retrieval model. So you can see how different people have interpretation about the retrieval process and how they place this matching process into its core. So each and everything is coming towards the matching process, and within matching process you need to have some mechanism to perform the match, because within the matching process you do not need to have anything to do. It is simply to perform the compatibility matching between the document and the query. That's it, right? So in the next lecture we will try to understand internally how retrieval model basically has this presence of similarity measure or similarity approach, similarity equation, right? Like for the Boolean system, you have you can adapt cosine similarity always, right? In the most recent advancements, people are using dissimilarity measures also. So having dissimilarity measure is one way. You can always have the negative approach also. Dissimilarity also is one of the way. So you can, if you select the relevant approach and ignore the non-relevant, that is one approach. And you can have the opposite of it, which is identifying the non-relevant first, and remaining will be relevant, something like that. So you can have this option to adapt similarity. You can have option to adapt dissimilarity measures, something like that, right? So most of the modern advancements has been done in this way, that they have both they have both matrices. Like in the case of multi-valued or maybe modern retrieval models, they are having two similarity measures to identify relevant and unsure. Similarity, in the most of the cases, most of the modern adaptive version of classical approach retrievals, they are having two ways, two retrievals, two similarity measures to perform that, right? So for today's lecture, that's it. These are the things which I wanted to share with you before going to start the fundamental or internal structure of retrieval models. These are the something which I wanted to share. Now, if you have anything to raise, you can let me know.